In the context of control panel construction for both United States and European applications, the standardization of control wire colors is a common pursuit. However, concerning the specific question of using light blue as a neutral conductor color within underwriters' laboratories, or all 500A compliant panels built for the United States market, certain restrictions apply. UL 508A, which serves as the standard for industrial control panels, outlines specific requirements for wire colors to ensure safety and clarity in electrical systems. Annex S of UL 508A provides guidance on wiring practices and color codes for control panels. According to UL 508A, Annex S, light blue is explicitly not a permitted color for neutral conductors in the United States. The standard mandates that only white or gray wires may be used for neutral conductors within control panels destined for use in the U.S. This restriction is in place to maintain consistency and prevent confusion with other conductor types, such as grounded or ungrounded conductors. The reason for this specific color designation stems from established electrical safety practices in the National Electrical Code, or NEC, which is the prevailing electrical code in the United States. The NEC also emphasizes the use of white or gray for identifying neutral conductors in electrical installations. While labeling the light blue wire at both ends and on the schematic might seem like a suitable workaround, it does not override the fundamental color code requirements stipulated by UL 508A. The purpose of color coding is to provide an immediate and unambiguous visual indication of a wire's function, which is essential for safe and efficient troubleshooting and maintenance. Relying solely on labeling can introduce the potential for human error and may not be sufficient in all situations, especially in emergency scenarios where quick identification is crucial. In control panel design and construction, adherence to UL 508 is vital for ensuring product safety and compliance with regulatory requirements. Using the correct wire colors is a key aspect of meeting these standards. Therefore, when building control panels for the United States market, it is imperative to use white or gray wires for neutral conductors, irrespective of any labeling efforts. Deviation from this requirement can lead to non-compliance and potential safety hazards. It is important to note that while UL 508 outlines the requirements for control panels specifically, these requirements often align with broader electrical codes and standards such as the NEC. The NEC provides comprehensive guidelines for electrical installations in buildings and other structures, and its provisions regarding neutral conductor colors are consistent with those found in UL 508A. This consistency ensures a unified approach to electrical safety across different applications. Furthermore, when dealing with control panels intended for both U.S. and European markets, it is crucial to understand the differences in wiring color codes and standards. In Europe, the color code for neutral conductors may differ from that in the United States. For example, blue is commonly used as the neutral conductor color in European electrical systems according to the International Electrotechnical Commission, or IC, standards. Therefore, if you are building a control panel that will be used in both the U.S. and Europe, you may need to use different wiring configurations to comply with the specific requirements of each region. This might involve using white or gray wires for neutral conductors in the U.S. panels and blue wires for neutral conductors in the European panels. Proper labeling and documentation are essential to avoid confusion and ensure that the control panel is correctly installed and maintained in each location. In summary, when constructing control panels for the United States market, always use white or gray wires for neutral conductors, as required by UL 508 and the NEC. While labeling can provide additional clarification, it does not replace the need to adhere to the fundamental color code requirements. For control panels intended for both U.S. and European markets, be mindful of the differences in wiring color codes and standards, and take appropriate measures to ensure compliance with the regulations of each region. Doing so will help to ensure the safety, reliability, and compliance of your control panels. Additional considerations in control panel wiring include the selection of appropriate wire sizes, insulation types, and termination methods. Wire size should be selected based on the ampacity requirements of the circuit, considering factors such as conductor temperature rating, ambient temperature, and dirting factors for multiple conductors in a raceway or cable. Insulation type should be chosen based on the environmental conditions and voltage requirements of the application. Common insulation types include polyvinyl chloride, or PVC, cross-linked polyethylene, or XLPE, and thermoplastic high-heat nylon, or THHN. Termination method should be selected to provide a secure and reliable electrical connection. Common termination methods include crimp-on terminals, screw terminals, and push-in connectors. Proper wiring techniques are essential for ensuring the safety and reliability of control panels. Wires should be neatly bundled and routed, with adequate support and strain relief. Connections should be tight and secure, and all unused wire ends should be properly insulated. Regular inspection and maintenance of control panel wiring are important for identifying and addressing potential problems before they lead to equipment failure or safety hazards. Inspection should include checking for loose connections, damaged insulation, and signs of overheating. Maintenance activities may include tightening connections, replacing damaged wires, and cleaning dust and debris from the panel. By following these guidelines for control panel wiring, you can help to ensure the safety, reliability, and compliance of your electrical systems. Remember to consult the latest editions of UL 508 and the NEC for the most up-to-date requirements and recommendations. Furthermore, consider the specific requirements of the application and any applicable local codes or regulations. Proper planning, design, and execution are essential for successful control panel wiring projects. It is important to have a thorough understanding of the electrical system requirements, the applicable codes and standards, and the proper wiring techniques. With careful attention to detail and a commitment to safety, you can create control panels that are both reliable and compliant. The National Electrical Code provides detailed tables and guidelines for determining the appropriate wire size for various ampacities, voltage drops, and installation conditions. These tables take into account factors such as the conductor material, insulation type, ambient temperature, and the number of conductors in the raceway or cable. It is crucial to consult these tables and apply the appropriate dirting factors to ensure that the selected wire size is adequate for the intended application. Voltage drop is another important consideration in wire sizing. Excessive voltage drop can lead to reduced equipment performance, overheating, and even equipment failure. The NEC provides guidelines for calculating voltage drop and recommends limiting voltage drop to a maximum of 5% for power circuits and 3% for lighting circuits. To minimize voltage drop, it may be necessary to increase the wire size or shorten the length of the circuit. In addition to wire size, the insulation type is also an important consideration. The insulation must be rated for the voltage and temperature conditions of the application. Common insulation types include PVC, XLPE, and THHN, each with its own set of properties and applications. PVC insulation is a general-purpose insulation that is suitable for many applications. XLPE insulation has a higher temperature rating than PVC and is more resistant to moisture and chemicals. THHN insulation is a high-temperature insulation that is commonly used in conduit installations. The selection of appropriate termination methods is also critical for ensuring reliable electrical connections. Crimp-on terminals provide a secure and gas-tight connection and are commonly used for terminating wires to equipment. Screw terminals are another common termination method, but they must be properly tightened to ensure a reliable connection. Push-in connectors are a relatively new type of termination method that offers quick and easy installation, but they may not be suitable for all applications. Proper wiring techniques are essential for ensuring the safety and reliability of control panels. Wires should be neatly bundled and routed, with adequate support and strain relief. This helps to prevent damage to the wires and ensures that they are properly supported. Connections should be tight and secure to prevent loose connections, which can lead to overheating and equipment failure. All unused wire ends should be properly insulated to prevent accidental contact and short circuits. Regular inspection and maintenance of control panel wiring are important for identifying and addressing potential problems before they lead to equipment failure or safety hazards. Inspection should include checking for loose connections, damaged insulation, and signs of overheating. Maintenance activities may include tightening connections, replacing damaged wires, and cleaning dust and debris from the panel. Dust and debris can accumulate inside control panels and can contribute to overheating and equipment failure. By keeping the panel clean and free of debris, you can help to ensure its long-term reliability. In addition to the above considerations, it is also important to follow any applicable local codes or regulations. Local codes may have specific requirements for control panel wiring that are not covered by UL 508 or the NEC. It is important to be aware of these requirements and to comply with them. Proper planning, design, and execution are essential for successful control panel wiring projects. It is important to have a thorough understanding of the electrical system requirements, the applicable codes and standards, and the proper wiring techniques. With careful attention to detail and a commitment to safety, you can create control panels that are both reliable and compliant. Remember to consult the latest editions of UL 508 and the NEC for the most up-to-date requirements and recommendations. These standards are constantly evolving to reflect new technologies and best practices. By staying informed about the latest changes, you can ensure that your control panels are always up to code. Furthermore, consider the specific requirements of the application. Different applications may have different requirements for control panel wiring. For example, a control panel used in a hazardous location will have different wiring requirements than a control panel used in a non-hazardous location. It is important to understand the specific requirements of the application and to design the control panel wiring accordingly. Finally, it is important to have a qualified electrician perform the control panel wiring. A qualified electrician has the knowledge, skills, and experience to safely and effectively wire control panels. By hiring a qualified electrician, you can ensure that your control panels are wired correctly and that they meet all applicable codes and standards. In summary, control panel wiring is a complex and critical task that requires careful planning, design, and execution. By following the guidelines outlined above, you can help to ensure the safety, reliability, and compliance of your control panels. Remember to consult the latest editions of UL 508 and the NEC for the most up-to-date requirements and recommendations, and to consider the specific requirements of the application and any applicable local codes or regulations. Furthermore, it is important to have a qualified electrician perform the control panel wiring. With careful attention to detail and a commitment to safety, you can create control panels that are both reliable and compliant.